right. Our next speaker is Anna Filina. Anna is she's a consultant at Zenika Montreal. So I know her personally because I'm also from Montreal. She's a specialist in TDD and an expert in dealing with nasty legacy code bases. She is a famous public speaker. I was lucky to see her live at Bulgaria PHP last year. So I'm really glad we have her today. Because from my experience, her talks are always full of concrete and useful advice. So today, she will share her experience on working on very old code bases, so you can learn from it. Anna, you're up.
Thank you for the introduction. Hi, everyone. Let's talk about rewriting legacy code. Disclaimer, my hair is bad. No, not an essential service. Also, the T on my keyboard is broken since March, and I cannot fix it, also due to the pandemic. So I will have probably some typos, so bear with me. Why did I choose this image? Because old code likes to blow up in your face, or maybe that's what you'd like to do to it. You'd like to just nuke it and start from scratch. This talk will focus on PHP, but the advice is quite generic, so that even the parts that don't touch PHP will be useful for everyone, no matter your language. So I know I've been introduced. I've been coding since '97. I do legacy archaeology. I like to automate tests. I give talks and workshops, and I have some YouTube videos that you can watch. So why should you listen to me when it comes to legacy? Well, I've been dealing with legacy for a very long time. In the last 12 months, I have rewritten 16 applications, currently working on application number 17 and 18. So all of these are legacy rewrites, and that doesn't count, advice gigs for, helping people understand what legacy is all about. All right, let's dive into it. Let's say you inherited a 10-year-old code base, or maybe it was a 15-year-old code base, or perhaps a 20-year-old code base. So yeah, I do occasionally work with code that was written in the year 2000. So what was the web like around that time? Well, this is Yahoo back in 2000. So the web was 600 pixels wide. Conferences would just reject a profile photo if it was only 600 pixels wide. So that gives you an idea of where we come from. Other things around that time, we obviously had the Y2K bug. Internet Explorer 5 was around. I know that people really celebrated when Internet Explorer 6 died, but we had to survive Internet Explorer 5 back then. ICQ was only starting to be cool. So it's been a long time. Background music in websites, that was very common. And if you had rounded corners, you were the cool kid on the block. And of course, you had these GIF animations everywhere, torches and other stuff, under construction signs. So your code, if you inherited something that is 20 years old, your code was written around this time. So it kind of makes sense that it didn't follow all of the today's clean code standards. So I want to share some stories and advice about the types of migrations you can do and how to do them well. But before that, let's talk about legacy sadness. So there are many ways people define legacy. Some define them by lack of tests, but I would argue that even when you have tests, they have to be of good quality. Otherwise, it doesn't really help. So what makes me sad when I look at legacy code? The methods, they can exceed 1,000 lines. I have spoken with someone just a couple of months ago who told me that they had an application. The entire application was written inside one method, and that method was 14,000 lines long. So it is huge. The method can mix, obviously, concatenate SQL, do some PHP, concatenate a whole bunch of HTML, and it just drags on for hundreds and hundreds of lines. It can receive a dozen arguments, or maybe several dozens of arguments of arbitrary types, of course, because we're dealing with PHP, also in Ruby and other scripting languages like vanilla JavaScript. So you have these arbitrary types, which open up a whole bunch of problems in themselves. And also you could access, that method would access properties on the object, but these are potentially undefined because in PHP you don't have to define something. You won't get an actual error when you try to access them, only if you try to do something with it. So that's an interesting case that just keeps repeating in all the legacy that I inherit. And then those properties, they can be undefined or maybe just be null at that point. And unless a child of this class has set them maybe 10 method calls ago, these are potentially null by the time you use them. So you have all of these nulls floating around. And the thing about setting things very early on, the problem with that is unless everything is called in a perfect order, things will not work. But you cannot know that in advance because you just assume that if you call a method, it's going to work. But it's not going to work because you need to call things in a very fragile order. So that makes code very, very brittle. And then you have interesting method names like _new or _new2. And of course, once you start, rewriting these methods with _new2, people don't necessarily clean up the old code once they stop using it. So it just floats around, maybe even used in one place, and it just sticks around forever. And then you don't really know which one you should call, which is the correct one. There are no tests, so you can't really understand the behavior. So there's a lot of dead code like that. I'll have a whole section about that. Right. So the languages that have dynamic types are the hardest, I would say, when dealing with legacy, because you can have null pointer exceptions of every flavor. I gave a talk several months ago where I had, I think, 10 slides just on null pointer exceptions. I gave dozens of examples, and I had to stop myself at some point because I had more, but at some point I had to move on to another topic. But null pointer exceptions are very, very common in JavaScript and PHP. And then you can have interesting things like once you have nulls or like random types being passed to your method, you can do something interesting with it, like attempting to split an array. So I have had errors like that, not in production, but at least in development, where I call a method and you can give it an array and it's going to attempt to split it. Usually you would want to split a string, by a delimiter, let's say a comma, but then they try to split an array. That doesn't work. People can attempt to divide by null. Of course, dividing by 0 is an exception, but dividing by null just instantly teleports you to a different dimension. People can attempt to count the number of elements in the float. So you would expect to receive an array, but instead, for some reason, something was cast incorrectly or received from the wrong data source. You read the wrong cell in an Excel spreadsheet, and then now you have a float. And you attempt to count the number of elements there, and you're not getting the right, the result that you're expecting. And then you can attempt to get the max. So max is something you would use for normally integers or floats. You would check you would get back the highest of the numbers that was passed. But in PHP, you can just throw arrays in there. And those arrays, their items can be of mixed types. And what's even more interesting is that this, in older versions, does not even generate an error. It's actually going to attempt to do that. So I'm not gonna tell you, what is possible, but I will let you experiment with this tonight just for fun and see what you can throw at max. You can even, try throwing an exception at it, like try to pass an exception as one of the array elements and see what happens. And then you're going to have a maximum exception. So for those who are not familiar, this is a Dalek from Doctor Who. This is one of the enemies in the series. All right, so now that we know that we want to rewrite this legacy, here's how, before we succeed at rewrite, we're going to fail a few. And I have seen a lot of rewrite failures because, many people think that if only they were given a chance to rewrite everything from scratch, things will work out just fine. Like they know how this is, what it's supposed to do. They just need to write new code for it. Sounds simple, but unfortunately, almost all rewrites fail. I have rarely seen any rewrites succeed. I've been in one successful full rewrite, but a lot of them fail. Even the partial ones fail very often. Sometimes they fail multiple times in a row, despite budgets of millions of dollars. And I've been involved in a project like that. Unfortunately, only a pawn there, so I couldn't really steer the project in the right direction. But yeah, I've seen a company work, for several years on a project, fail the rewrite, get that failure to inform their next iteration, try it again, failed again, and try to rewrite for a third time. And I don't know what happened to that because I left before the end. So yeah, rewrites can fail multiple times in a row. And some of the reasons for that is often people start with a very ambitious new stack. So they can decide, hey, let's do microservices. And of course, they don't know how to write microservices, but they want to do it because they heard that it's going to make old legacy better. So they start with that. And then, of course, they've been using maybe Zen Framework 1 or CodeIgniter, so they want to move to Symfony. And after that, they want to use Docker because Dockerizing your environments is all the rage, which is good. I mean, all of these things are very good choices. So you want to Dockerize it instead of using Vagrant or some random development server. And since you're using Docker, and all these good DevOps tools, how about Ansible, for your deployments? Have a nice playbook. Then go with Elasticsearch because we've been at a conference. We saw that Elasticsearch is going to solve a lot of our problems. And then obviously we're going to have to go to the cloud. We're going to put things in S3 and other things. We're going to write some Lambdas later. Of course, we want to switch to GitHub because CVS is too old, or SVN or Mercurial just doesn't cut it anymore. Let's move everything to Git and GitHub or Bitbucket because it just works so well. They have enterprise level of accounts. And of course, since we're using GitHub, might as well switch from, I don't know, Jenkins to Circle CI, or if we don't have anything, let's have, continuous deployment because we need to use that. We've been talking about this for the last 3 years in our, this is a theoretical company, of course. We've been talking about this for three years. Let's finally move to that. And of course, we want to separate the layers. We want to have our API on one side and a front-end application on the other. So we're going to introduce React as well, as opposed to plain old JavaScript. So all of these technologies are very good. And I mean, this is something you would see realistically somewhere. But the problem is when you're switching from not using any of these to all of these at once. And sometimes it's not even to solve a real problem. Or maybe you're trying to solve too many problems at once. Sometimes people, as much as they don't like to admit it, sometimes they just want the opportunity to try all of these new things. And as fun as it sounds at first, once you start to get into it, if you don't have any experience with all of them at once, then you start having problems. Let's say you spend a day debugging your Docker container because you don't know how to use Docker. When you're new to it, it's pretty intimidating. There's a lot to learn if you're not a DevOps person. So people spend a long time debugging it. Once they're done, now they try to do something in React. They don't know React. They stumble upon another problem. They spend another day, searching things on the web. So all the time it's like stop and go. You always debug something. Something is breaking. You have no idea what's happening, and you make little progress, and it becomes frustrating very quickly. It's a lot of friction, So you just can't get anything done in the end because you're always dealing with all these new problems where, if you had just switched, let's say, to Symfony, maybe that would have been simple. Or, Symfony plus Docker, and that might have been enough. And maybe you would make the other switches once that step has been successful. So I find that, these ambitious tech stacks make a lot of projects fail their rewrites. There could be other ambitions. Again, these are good things. They're not bad. The problem is when you try to do everything at once. So people want to make their code follow the solid principles. They might want to introduce some test-driven development, which is, again, is great. But if you don't have testable classes, that might be difficult, especially since people always think that test-driven development is about unit tests, which is not the only type of tests. And I will show you, I have a whole section on how to test legacy. Strong typing, again, great thing. You can do that in, with PHP newer versions. You can have much stronger typing, and TypeScript for JavaScript also. So these things exist and people want to leverage them. But the thing is, the way the application works does not always easily lend itself to strong typing. So you will have casting errors, you would have things explode all over the place. If you go that route immediately without first making sure that it works on the new version of the language, you might have problems there. So what I would recommend for PHP, for example, is to use just type hints, like add var, things like that, or add param, and then pair that with some sort of static analysis that will tell you whether those types are always correct. So let the machine your code and tell you whether your type is always going to hold. So use your tools on the side instead of putting this directly in the code and make it blow up. Because the code has been working without that before. So introducing that now is just introducing a new possibility of things exploding. And also people, they expand the scope. They start just, they want to rewrite the project because they want to eliminate technical debt. But then they start rethinking existing features like, well, can we make this do that instead? Can we rework how all of that works? Can we maybe introduce new features? Since we're going to be spending so much time in the code, might as well add some new features. And, let's try Scrum. Again, all of these are good things, except that if you do everything at once, you will probably fail your rewrite because you'll be dealing with too many new things, too many changes, and there are only so many new things a person can deal with at any given time. So it's going to kill your team productivity. So what I recommend is to always start with the strategy. Well, first with the goal and then the strategy to achieve that goal. Because I know cracks, in the walls are pretty ugly, but that doesn't mean you have to rebuild the whole house. I mean, you can just fix the facade if that's the main problem. If the foundations are still holding, if the roof is not leaking, there's no reason to rebuild the whole house. Things might seem like a disaster when you look at the legacy code, but once you get to know the code, you realize that it's actually not that bad. And rewriting it would actually be a lot more effort than you anticipated. So there are multiple strategies, and I will go in depth on each one of them in a second. So one of the strategies is to just upgrade the version of the language. So for example, if you're working with PHP 3, you can upgrade to PHP 7.4 or 7.3 if you have some constraints with your servers. So you just want to upgrade your version. That's one approach. You might want to switch to a new framework. That's a lot more involved. So let's say you want to switch from Zen Framework 1 to Zen Expressive. I'll show you an example of what that looks like. And then you can do a progressive rewrite. Progressive rewrite means that you replace one module at a time, maybe even one class. Just replace small pieces at a time until you have rewritten everything. And then you can refactor stuff. You can also go the route of just refactoring. It is valid. It is a way to eliminate technical debt. It is quite involved. I'll explain some more details in a second. And then you can go for a full rewrite, which obviously I don't recommend, but it is a valid strategy that we still need to discuss. So regarding version upgrades, these are probably some of the easiest migrations that I've performed so far. I think I migrated 13 applications to a different version this year. And they were quite painless, I would say. So if your goal is to just upgrade the version, don't try to sneak other things into it. Just do it. It's an easy win. Some of the tools you can use for that is PHP Code Sniffer that can detect incompatibilities. So if you're using a different language, see if there's a library that can statically analyze your code and give you a report of all the things that do not match the version to which you want to migrate. So the way PHP Code Sniffer works is you give it your code base, you say, please scan it and check, compatibility with PHP 7.4. And it's going to give you a report of all the things that have been, removed or deprecated, or, arguments changed order. Some libraries have been dropped, or some extensions have been dropped. So it's going to give you a full report, and that is basically something that is actionable. Be careful because it's not perfect. It's not going to give you everything. You will find things when you run the code that have not been caught by PHP Code Sniffer, but it's a pretty good start. It's a pretty good start because then you can address those errors first, and then if you have anything else, then you will you'll find them as you probe the code. Some libraries, so when you start upgrading to a different version, some libraries might be easier to swap than to fix. So you can go ahead and fix PHP XL and all of the incompatibilities, but you can just swap it with a new library, which is compatible with the latest PHP version. It's called the PHP spreadsheet, and the interface is very similar. So the substitution is actually quite straightforward. So I would recommend that you actually look at all the libraries that fail and see which one can be upgraded or swapped, so that you don't have to manually fix all that. So, you don't spend time debugging all the dependencies as well. Obviously, regular expressions can help. You can get into the manual fixes later, but first see what you can automate with regular expressions. One word of advice: when you use regular expressions, once you have matches, apply them one by one. Apply the changes one by one. So if you have 45 matches, you replace, and then you don't replace all, just replace, go to the next one, replace, inspect the result, make sure you're not doing anything crazy. Or you can just apply all and see the diff in Git, do a Git diff. But make sure that you inspect after every regular expression that you apply. Make sure you carefully inspect the results, because I have seen regular expression disasters where it yielded basically non-compilable code. Parentheses and commas were off, and then it just leads to disaster. Rector is a tool, so Rector PHP, or I think it's just called Rector. It can automatically refactor things. So it's a library written in PHP, and you can use some existing, what they call rectors, some existing sort of rules to refactor things. I'll show you an example in a second. You can use those existing ones, or you can write your own. So I have used that to, find hard dependencies and move them to dependency injection. So you can do some really cool stuff with it. It's a steep learning curve, but once you take the time to master it, it is really a lot of fun. Like, it's great. It can just automate months worth of mindless work in a project. So, those projects aren't always small. Some of them can have hundreds of thousands of lines of code. You don't want to do them manually. And the problem with version upgrade is that you need to often freeze development, because if you start working on new features in the old version, you're going to move code around, and then by the time you're done with the version upgrade, code has diverged, and now you have to debug things all over again. So often that involves a development freeze. But luckily, version upgrades don't take too long, and they're usually done on projects that aren't often actively worked on. So often I find that version upgrades are pretty easy to accomplish, at least in my experience. So I talked about Rector. So one of the things that it can do, and we mentioned PHP XL as well, it can refactor your code from using PHP XL to using PHP spreadsheets. So you just change the dependency, and then you apply this Rector that's going to do all of these changes for you. So this screenshot has been, shamelessly lifted from the Rector's website, but, to compensate, I will give a shout out to Thomas Votruba, who is the creator of this awesome tool. So there are hundreds upon hundreds of existing Rectors that you can look through. And if you don't find what you need, you can create your own. Again, it's a bit of a steep learning curve, but once you get that running, it's really great. It's extremely powerful. This is a very simple example. I've been doing some pretty awesome stuff, refactoring. There's another strategy. You can move things to a new framework. And when you do that, you can start using dependency injection. So if you use, for example, I've done a lot of moves from Zen Framework 1 to Zen Expressive. And Zen Expressive allows for dependency injection. So this is really nice because it has a pretty good service container. And so dependency injection is probably the best investment into future testability, because you start separating your concerns a lot better, instead of having all of your stuff being forced to bootstrap pretty much your entire framework in order to test one controller. You can start sort of unit testing your controllers. So dependency injection is really nice. And you can automate large chunks of migration with Rector. I'll show you an example in a bit. Mostly custom Rectors, of course, because it really depends on where you're coming from and what you're moving to, what your code style is. You can use adapters. So let me explain. Let's say you're using an MVC framework, so you have a view which calls view helpers, like this format date. And so if you want to format the dates, it would accept arguments, certain types of arguments in a certain order. Or maybe it's going to output form elements. So it's going to accept certain arguments, but the new framework has a similar helper, but it uses different arguments, or maybe those arguments are in a different order, or maybe the first argument is not there anymore in the new version of the framework. So what you can do is use adapters. You create a class. So your view will actually call this class instead. So through the service manager, you inject a different helper in there, and that one will then delegate to the new helper. So it's like an intermediate to convert arguments. So you can keep sending arguments in the old way and then convert them to the new way. And that's usually a temporary patch, because of course you want to use the new framework the way it was intended to. But changing hundreds upon hundreds of views can be very difficult. So you can just create some adapter classes for that, and then eventually write a proper Rector to refactor things in the views in order to use the new approach. And again, you are going to probably need to freeze development for a much longer time. Changes to a new framework is a lot more involved. So an example of how you would move things to a new framework. So for example, in Zen Framework 1, or in many of the, actually most frameworks, I think, the way they work is they have a controller class, and that controller can have multiple actions. So you would have a product controller that can respond to an index action and a view action. And so these are then mapped through the routes file too. So URLs are mapped to these actions, sometimes magically. So not even explicitly defined. And so if you're moving something to Zen Expressive actually is different in the sense that it does not have a single controller class. Every action is its own handler. I'm going to show you a code example in a bit. So what I usually do when I work on that kind of migration is I would grab every method,
every action method, I will put that code into their respective handlers. And then those handlers will extend from the base handler, because you might have some other methods and properties in the controller class that that you don't want to copy paste all the time to every single index and view handler. So you have all the common methods in the base handler, and then the index view handler can then call those. So you kind of have that separation. And again, this is the first step. You can, once you finish everything, then you can go on refactoring things and making things cleaner. But at first, you are making a big change. You want to make sure it actually works before you go too far. Right. And then you move your route configuration, any other framework-specific configuration, you move that. This is where Rector can really shine, because I remember I've pretty much automated the splitting of that controller into all the handlers. And they, after all that, they almost work out of the box, and you just have to go through some of the best care errors and then remove them. So yeah, that saved me months of work very easily. I also use that to migrate about 8,000 lines worth of repositories. So from using one ORM to using a different ORM, which has a different interface. So you can the refactoring is pretty powerful. So an example of that would be, and if you're not into PHP, you can just gloss over it. Basically, the idea is you have the index handler, extends the base handler, which implements the request handler interface. This is how Zen Expressive works. So basically, Rector will create this class for me. It's going to find all the things that are injectable, and it's going to inject them into the constructor. And then I have my handle method, which then returns an HTML response. I don't have to refactor my my templates, so the product index template remains the same, no change there. So the idea is I keep the variable names, very important. What you want is to be able to look at the old code and sort of be able to compare. So when things break, like let's say you made this move to the new class, things now break, you want to be able to compare it. And if you have changed things significantly, if you started refactoring stuff, splitting methods, renaming variables, you won't be able to compare, and it will be much, much harder to debug. First, make it work, and then you can refactor. A progressive rewrite, something I actually like to do a lot. It doesn't require a complete freeze of the development on the old code. Basically, you can rewrite, by class. So you can split a God class into smaller classes. You can define better interfaces, write tests for it. You can migrate by module. So you take like a chunk of the code at once and you rewrite it. This is my favorite approach, by the way. By module, so you can say, this URL is not going to this, not even to this framework, not even to this language. It goes somewhere else, as long as it responds to the request in the same way by using, by reusing the session, by reusing the database, all of those shared resources. If it can do that, then your module is pretty much, interchangeable. So you can have a navigation. Let's say you go through a shopping cart, and one of the steps is going to a completely different application, basically. But it just, the URL points to that application, and you can do some really nice, swapping just the parts that you want to migrate first. So the application can basically keep running. It's like changing your engine while you're on the road, or changing parts while the car is still running. So it's really nice. So yeah, you can switch languages as long as you treat HTTP requests the same way. When you do a progressive rewrite, what you don't want to do is do like a one-for-one migration of the code. What you want to do is what's called design extraction. So it's a way to avoid being biased by how the code is working, because it might have things in there that are poorly designed, no longer used. So what you do is you take the old code and then you extract the design. And then you go to your clients and whoever signs off on the on features, and then based on their understanding of what the features basically need to do, you can come up with a completely new design. At that point, you can completely discard the old design. And from the new design, now you just need to write new code and just make sure to integrate it into the same flow, and you're good to go. Now, when you go the route of just refactoring, so I personally don't do just refactoring. I rarely go on a refactoring crusade because I think that in itself it brings little value. Things have to be paired with some sort of business value. Like there needs to be a purpose to that. So some of my criteria for refactoring is, do I actually need to change this code? So if I have a bug that I need to fix or like a feature that I need to extend, then I might refactor the code with which I'm working because it makes it more extendable, more testable. There's an advantage there. There's an immediate advantage, and you don't have to justify the refactoring. You know that you are working on adding a feature to a legacy code base, so you know it's going to take you like maybe 3 or 4 days or maybe a week. And you just go ahead and do the refactoring wherever you see appropriate. The other thing is sometimes I don't directly change that code, but I need to, it's hard to understand, but I need to work with that. So it's kind of like code that's touching the code that I'm changing, and that is constantly interfering with what I need to change. So sometimes I'll just go ahead and fix that properly. And from there, I can then fix this bug much more easily. I'm not going to talk too much about refactoring because there's going too fast. There's a great book by Martin Fowler that you can read. So it explains, all the different ways that you can refactor your code. Let's talk about full rewrites. I highly discourage full rewrites. There are some criteria. So I have done a full rewrite. My criteria is basically, can you disregard existing features? Like, do you actually care about what it's currently doing? If we need to do pretty much something else, along those lines, but we want it to work in a completely different way, then obviously keeping any existing code doesn't really make sense. If it has also few integrations with other systems, so if a system expects you to produce a certain CSV file to deposit on their FTP, then that piece will probably have to be kept, or at least refactored, but not completely scrapped. But yeah, if you can pretty much trash the old database, trash the old code, then yes, you can rewrite. If not, you would need a team that is experienced specifically doing full rewrites, which I have never met. I just don't want people to tell me, yeah, but we did it successfully. Well, if you did, good for you. It would be a pleasure to meet you. For now, in my head, this is still very theoretical. So basically, a full rewrite is when you need to write a new app. And that happened to me when I was rewriting an application that wasn't even a web application. So they wanted to create a web application. They wanted completely new features, or a lot of new features. So we decided to rewrite because there was no point in trying to do anything with the old one. There wasn't enough to salvage really from the old application. So when you start refactoring in any way, rewriting in any way, you can spot problems early by using PHP Storm inspections or whatever IDE you're using. All those warnings, turn them on, see what they're saying, find potential bugs there. You can use something like Psalm, which is a static analysis tool. It can start with an auto-detected level, and then you can go ahead and tune it up once you fix all those problems. I'm going to have to speed up here because apparently we don't have much time left. Beware of unknown unknowns. So before you touch a single line of code, you need to go digging. Dig through the docs. Take the time to actually look at the documents, even if you just skim all of them. So maybe there are no docs. In that case, too bad. Maybe there are too many docs and they have very little relevance. Still, look through them. Make sure to find what you need, because even in the worst docs, you might find a gem that will save you lots of time because it lists, all the API endpoints and the format that they receive, and you can just scrape that and convert it into actual tests. The docs can also be outdated or misleading. Just verify everything. Don't assume that what you read is correct. So check with somebody in the company. Tests. Sometimes you have no tests. Sometimes the tests don't compile or don't run at all because they have been there and nobody ran them for like a year or 2 or 5. Those tests could also be failing. If they're not failing, maybe they're brittle because they require a very specific environment to be set up, or maybe they have interdependencies. So if you run them in a different order, they start failing. Maybe they're just unreliable. Maybe you have like a whole bunch of tests, but they don't actually test anything that's logical. And if you change the code, they're still gonna pass, so they're not really reliable. So you have to take the time to understand what kind of tests you're dealing with and whether you can leverage them or you're gonna have to write your own. I have a section on that. Regarding dead code, this will slow you down if you don't deal with it. Things that are very interesting, you can have an application with unused endpoints. So these are endpoints, but there is no link to it anywhere, and they have been completely abandoned sections. I had a client with over 300 endpoints, and 40% of them were unused or abandoned. Also, delete any commented out code. It's just gonna constantly slow you down because your regexes will find matches in there. You can also have unused classes or methods, but be very careful about what your IDE reports to you. Exercise extreme caution, because in languages like PHP, you can have you can call arbitrary code using func, call user func or something, and it's not necessarily picked up by your IDE. So be very careful. If you have duplicated code, like a bug that's repeated 80 times, you might want to merge it so you don't have to deal with it 80 times. Now, regarding testing approaches that I promised you, for a version upgrade, usually, so again, this is just what I do. This is not necessarily what you should do in every scenario, but this is how I usually approach it. For a version upgrade, I start with small tests. So like with Behat or Cypress, it's basically high-level tests that don't really try to test the behavior, just make sure that all those endpoints don't blow up, which is what would usually happen with a version upgrade. So these tests, you write them for the old code, and they have to survive the new code as well. And that's how you compare that you haven't broken anything big. Of course, you're going to have other tests later on, but this is a good safety net. Then you fix the code, and then once you fix it, you can write unit tests not for everything, of course. You write unit tests if you have like new code, refactored code, or things that constantly fail in end-to-end tests at the end, which is how you would validate that the version upgrade has been successful. So yeah, I don't write unit tests for code that is inherently untestable. For a new framework, very similar approach. Smoke tests should work on both. And then you do the migration, and again, unit tests for whatever new code that you wrote. Of course, if you have any sort of big change in there, that would also require proper acceptance tests. But this is the general approach. Then for progressive rewrites, because we are starting with a new design, so I approach all of those new endpoints as basically a greenfield project. So I would write acceptance tests, which should work on both versions. Then I write unit tests. So acceptance tests are like Behat, for example. You hit an endpoint and make sure that given that request, it produces the desired response. Unit tests for any new code, of course, or code that you have heavily modified, and then you write your new code. So test code, you don't have to write all the unit tests up front, of course. When you do just refactoring, again, acceptance tests, unit tests for the code that you want to write, and refactor. So similar to the previous one. Now, as for preparing your environments, I think I might be a couple of minutes over time because I still have a couple of slides. But to prepare your environments, you're going to need a local and development environment. and the organizers feel free to stop me if it's too bad for an overrun.
That's fine. Go ahead.
Thank you. So for the local environments, I would recommend strongly Docker. I am currently in the process of moving some Vagrant machines to Docker. It is a steep learning curve. You will hate it until you really start to understand it. It might take you months. If not, if you have a DevOps person, if you have someone familiar with Docker, leverage their knowledge. But yeah, once you have Docker running properly, you're just going to love it because you can switch between, different languages. Like, oh, now I'm going to run my tests in PHP 5.3 and now I'm going to run them in 7.4 and I can compare. It's really great to be able to do things with Docker. So I usually have a baseline image and then I have a migration image. So baseline is the code that I was originally provided with and the environment where it currently runs. And the migration image is the target. And these usually match whatever server, Vagrant, whatever information we can find on what the current environment is like. So in my Docker Compose, just abbreviated, you would see services like PHP, which is, I have two branches. I have the baseline branch and I have the migration branch. So for the baseline branch, this will be a PHP 5.3 machine. For the migration branch, that will be a PHP 7.4 machine. The MySQL version that's running, acceptance for your acceptance tests. I separate them from the actual PHP container because if I want to run bhat, I don't want to be forced to run it on PHP 5.3, which might not even work. I want to be able to use the latest and shiniest because acceptance tests are just going to call the other container via HTTP request. They don't actually communicate with code directly. It's a black box text test. So I can run them independently, and I can also bootstrap the application with a different database because I would want to constantly reload the database and stage some data for the acceptance test. So I have those 4 containers usually. Some gotchas, things like you want to pay attention to the MySQL modes. When you, because in the SQL mode you can do things like what happens if your primary key is 0. Based on the MySQL mode, it's going to treat it differently. If you use Composer, I hope you do in PHP, run Composer required from inside Docker, because what you want is to end up with a composer.log that is specific to that environment, right? Not your local, like your host machine's environment. So if my Mac runs on PHP 7.4, I want to make sure that my dependencies are installed for PHP 5.3 as in the Docker. So I run the Composer commands from inside Docker, and then I commit composer.log. So all I have to do when I switch branches is just Composer install, and that's it. You want to anonymize your production database. You can just limit or truncate some of the tables to have a smaller subset, and then replace all the data that is sensitive. Because you're rewriting an old application, you want all the sort of garbage data that comes with it because you need to account for all of those edge cases. Emails, very important. Don't allow your servers to send any kinds of emails. Send them to a relay, like a debug mail, mail trap. If you don't know how to set it up, find somebody who's well-versed in system administration, or take the time to learn it. It's going to be useful in the future. But yeah, set up your server to forward all emails, not within the application, but just all emails that come out of the server. Make sure they are sent to a very specific mailbox, and you can actually inspect the results. For your staging environment, basically the same setup as locally. You have a baseline server, you have a migration server. If you have any configuration in your staging, point it to sandboxes so that you don't make actual credit card charges, so everything has to go to sandbox. And then you can compare things by running something like Cypress. So Cypress is an extension to Chrome, and it can basically record a scenario, and then you can play it on one server, but then you can play it on the other server, and it can give you a visual regression sort of comparison. So it can tell you, oh, look, these icons have been inverted, or this thing is not centered, your CSS is broken, whatever, or it's not the right page at all. So it's going to give you all of that. So this is a very nice tool that we've started using only recently, and so far we love it. And that is it for this talk. I am only 5 minutes over. Sorry for that. Do we have time for questions?
Yeah, I was writing that we won't have time to tackle the question because we have many questions, but what I will do is I will forward them on Twitter so you can answer them when you have time and people can find it. But yeah, thank you very much.
With a hashtag or something. Yeah,
thank you. I will use the hashtag. Thank you very much for your talk. It was amazing. Thank you everyone for attending. We're not getting a break, a 10 minutes break, and then we will move with Christophe Thibault for the next talk. Thank you, Anna.
Thank you very much.